Okay, so in the example from our review, we have s of x equals square root of x minus 1. We have n of x. It says to find the domain of the composite of n of s. So my s function, n of s is the same as n of s. Sub it in. Now I plug it into the n function and simplify. The square gets rid of the square root sign. When I simplify, I get x minus 1 minus 2, which equals x minus 3. So when I look at this result here, this is the composition, and there's no restrictions here on this function. So the domain could be all real numbers. But you also have to look at the inside function of the composite, which is s of x here. And there is a restriction up here. So again, you don't want this to be a negative number. So an easy way to figure it out, we can say that x minus 1, sorry, this is going to hurt your eyes. X minus 1 has to be greater than or equal to 0. So just solve for x. We get x is greater than or equal to 1. So all real numbers, or so x is greater than or equal to 1, or all real numbers greater than or equal to 1. Okay, the second one, you didn't really have to do the domain. It was pretty complicated. So again, to find the domain, check the composite, if that is what it is asking, or the function. So here, again, for a composite, check the restrictions on the answer and the inside function. So in this case, we have m, n, and the composite. This is the composite of m of n of x. So if we want the domain of this here, our restriction on our answer is that x cannot be equal to 0. And actually, before I write that, let me check the inside function too. The inside function, if I look at this restriction, it's the same thing as the composite answer. So it's going to be all real numbers except 0. Or you could say, you know, x x cannot be equal to 0. This is really the better answer here. Okay, so here is the answer for 3B for our review. The answer 1, 6, 2, 1, 3, 2, and 4, 3. So we have our function.